One of the ways microservices communicate with each other is through the endpoints exposed by each microservice. The changes to the interface or contracts of these microservices can impact the client's functioning accessing these services. Though microservice architecture accelerates the delivery of new functionalities into the application, as we can run and test microservices in isolation and evolve them autonomously, any change to these contracts must take into consideration the impact it can have on these clients. Welcome to Omega Codex. My name is Sanal. As we continue our journey on the .NET Microservice series, today we'll talk about how to manage the changes to API endpoints in our services. If you haven't watched the previous videos, follow the link here to get started. I recommend watching those videos first, but you should be able to follow this video even without watching previous videos. So coming back to the topic of managing changes to API endpoints, I am talking about API versioning. It's a good practice to version the API endpoints like we have versions of code or applications. You can achieve it in multiple ways. In this video, we will discuss what those different ways are. So let's get started. Welcome back. As we progress through the development process, it's imperative that the business requirements change over time. This requires sometimes adding new collection of resources, the relationship between the resources changes, and also the structure of data in these resources might change. Updating a web API to handle these new requirements is a straightforward process. But what we need to consider is the impact it will have on client applications consuming these APIs. Developers who are designing and developing these APIs will have full control over the API, but they may not have the same degree of control over client applications. It could be developed by another team or maybe a third-party organization working remotely. Versioning an API enables it to describe the features and resources it exposes. The client application can then send requests to a specific version based on the feature or resources it needs. There are several approaches to implementing versioning: URI versioning, query string versioning, header versioning, and media type versioning. URI and query string versioning are the easiest to implement. Header versioning is not as explicit and straightforward as others, but it is still a good approach. Same applies to media type versioning. URI versioning is the simplest. The version can be set by using a route attribute in the web API controller as shown here. It makes the version explicit in the URI, v1 in this case. The mechanism is simple and depends on the server routing to the appropriate endpoint. In query string versioning, rather than providing multiple URIs for each version, you can specify the version using a query parameter appended to the HTTP request as shown here. The version parameter should default to a valid or meaningful value such as 1 if it's omitted by older applications. One advantage over URI versioning is that we always use the same URI, but just depends on the code that handles the request to parse the query string and send back an appropriate response. In header versioning, rather than appending the version number to the query string or changing the URI, you can implement a custom header that indicates the version of the resource. This approach requires the client application to add the appropriate header to any request, although the code handling the client request could use a default value like 1 if the version header is omitted. The example shown here uses a custom header named API version and value is 1.0. So the value of this header indicates the version of the web API. When an application sends an HTTP request to a web server, it should specify the format of content that it can handle using accept header. Frequently, it is used to allow the client app to specify whether the body of the response should be XML, JSON, or something else. However, it is possible to define custom media types that include information indicating the client's expected version. This example here shows a request that specifies an accept header with application/my.company.v1 plus JSON. The my.company.v1 part indicates that it should return version 1 of the resource, while the JSON part specifies that the format should be JSON. The code handling this request is responsible for processing the accept header and process it as far as possible. The web server confirms the format of the data in the response body by using the content type header and specifying the same value. If the accept header does not specify any known media type, the web server could generate a HTTP 406, that is not acceptable response, or return a message with default media type. This approach is considered the purest to REST constraints but can be trickiest to implement. Coming to the complexity of implementing it, there is an easier way to get this done with a NuGet package. The package name is ASP.versioning. It has packages for both .NET Framework and .NET Core. It lets you add versioning to API applications and also applications that use OData 4. So let's jump back to our microservice application and see how we can use it. By the way, if you have followed me this far, I hope you are liking the video. So please go ahead and click the like button. If you haven't subscribed to the channel, please do subscribe. Thanks for doing it. Let's move ahead. So we have our project which we had created in the previous video. I made few modifications from the last time, so I have added few methods. So in the last video we stopped at where we created one endpoint just to get the items and we were able to access it using the Swagger UI. So I have gone ahead and added few more methods. I also added the produces response type attribute just to mention what kind of the responses it would give out. Also, I added methods to get a single item, update an item, add item and delete item. So all the usual REST endpoints, the CRUD operations. So that I have added to this code. So let's get ahead with implementing API versioning for this project. To start with, as I mentioned, we will take the easier route, that is, rather than implementing the custom logics for our API versioning mechanism, we'll use a ready-made NuGet package called API.versioning. The package I'm talking about, this one, ASP.NET API versioning NuGet package, and it has various flavors. It has a web API, that is .NET Framework web API NuGet package, the one with web API and OData. Similarly, we have ASP for ASP.NET Core, and we have for ASP.NET Core MVC applications, we have for ASP.NET Core and OData, and there are some additional NuGet packages here. So we'll start with, we'll go ahead and install a NuGet package. Let's start the terminal. So let's add the package, .NET add package asp.versioning.http. So that's what we need for our web APIs to support versioning. So let's add that package. So now it is installed. Let's come back to program.cs and add this API versioning to our project. So it's very simple to add. It's called add API versioning, and with this the default setup is ready. Now let's do some customizations here. So we want assume default version when unspecified. By turning this on, if the client application doesn't specify any versions, so it will fall back to the default version, whatever we specify as the default version. And let's put default API version as new API version, and let's call it 1.0. So that is 1.0 is our minimum or the default API version. So with that, we have enabled API versioning for our project. Now we can come back to our controller and we can specify our API version for this controller. So the API version for this controller is 1.0. Now let's make a change. So what I'm planning to do is create one more version for the get items. So creating a second version for the get items endpoint which we had. So let's just copy this function and call this one as v2. So now since we have two methods here with the same endpoints, obviously it would give an error when we try to run it. When we will try to access these endpoints, it will not know which one to pick, and obviously it will give an error for us. So to resolve that, what we have to do is to map each of them to their own version. So we'll map this one, the old one, to map to version 1, and we'll also come here and add API version 2.0, and let's copy this attribute and put it as 2.0. So now this method is mapped to version 1. So whenever we will be accessing version 1 of the endpoint, this one will be called, and for version 2, this is the method which would be called. For other remaining methods, we are not creating a version, so it would work for both versions, and we have not specified any map attributes because we don't need to. We are only changing one endpoint, or we are creating version for only one endpoint. Rest of them are remaining same, so even in the second version they are going to behave the same way. So now that we have added, what we will do is we'll create a new view model class. I'll just copy a class file. So I've created a new view model for catalog item, and this is what I want to return as response instead of the catalog item which we were initially returning, which had a lot more attributes. So I don't want to return those attributes. I just want to return this one. So let's come back to catalog controller. We'll go back to the version 2 method. Also I will create an extension method to add some extension methods. Very intuitive. So let's call it object extensions, and I will copy some code to just make it static. And I have two extension methods. One is to just convert this catalog item to a view model, and then which converts a list of catalog items to list of catalog item view model. So we have these methods, and I'm just setting the required properties. I could have used an automapper or something, a library, something like that, but I didn't want to complicate it for now. So let's keep it simple, and let's come back to our controller, and here I'll just call the model like that, and we'll change this to catalog view model, and this one will change to catalog view model, and we'll change this as well. So you can see immediately it started giving error, and we'll change this, and need to make some additional changes for this. So I'll just include x.catalog brand and catalog type. Since I am adding these two values, the name of the brand and type of the brand, so I'll include those as well when I'm querying my data from the DB. Let's add it here as well, and that's it. So with this, we have implemented the default API versioning. So the default API versioning for this NuGet package is query string versioning. So let's run and see what impact we have made to the Swagger. Okay, so you can see that our Swagger is not able to understand the change we did, and we'll need to do some modifications to address this. So let's go back to our solution and do some modifications. So first is we will create a new folder, filters, and we'll create an IOperation filter for our Swagger. So let's call it Swagger default values, and we will derive it from operation filter, which is part of the Swagger generation, and let's implement it. So I'll put some ready-made code here. Now we will need to install one more package from ASP versioning NuGet package, and that's our API Explorer. So there is another package available for versioned API Explorer, and if we see here, we have an ASP versioning API Explorer, which is for the .NET Core application. So we will add this. We need to add this NuGet package. So let's come back to the terminal, add package. Okay, now that it is added, so now this is gone. So we'll talk about this deprecated flag, but let's move ahead and look through this code. So through this, we just update the responses of the operation based on the API description settings, and then we loop through the parameters, and in the API description, if we have mentioned any details about those parameters, so those are being updated. So now let's add one more item. So let's create one more folder called options. Okay, and let's create a new class, call it configure Swagger options, and we will inherit it from iConfigure options of Swagger brand, and let's implement the interface. Okay, we'll add few. So we'll set up the constructor, and we'll define the. So we are here through provider. We are looping through the API version descriptions, and we are creating an OpenAI info. So for each version, we are defining that info. So now let's come back to program.cs and first add our options. So before we do a Swagger generation, let's add transient of iConfigure options, Swagger gen options, and in that case, we want to create an instance of configure Swagger options. In Swagger generation, we will just call looks.operation filter. We want our Swagger default values. One more thing we have to do is just call add API explorer. So with that, we should be able to see our Swagger UI. So let's run it and see how does this come out. Well, we still have failure. So let's check what's the issue. Okay, I think we missed updating here. We have this for each description, API description, we want a Swagger endpoint, and let's call it Swagger description group name .json, and we want log API description group name. Okay, so now let's run, and hopefully this time it will run. And it is loading now, so we can see that we have the version number here, and we also have the version number drop down here. And if you see, so in this the parameters are this, and now we have an additional query parameter, which is the API version. This is the name by default given by the NuGet package, and we can specify whatever is the version here. Okay, so let's try with this and execute. So we get the response as we are getting version 1. Let's try putting 2 here, and we can see that we are now getting version 2 data. So we could always switch from here also, but since it gives you the option to change here, we can test it from here also, and we can see now it is bringing data from the version 2. So this way we have implemented the query versioning. In this case, since our changes were less, we only wanted to update 1 or 2 actions, we could do it in the same controller. We could also create it in a separate controller. We can create another controller and with either with a different name like catalog v2 controller, or a preferable approach is to do it using namespaces. For now, let's check all the different types of API versionings we can achieve using this package. So the next one we will check is URI versioning. It's very simple to change the same controller to use URI versioning. What we have to do is just update this root attribute to use a version number for URI versioning. So we'll just add API. We don't need to add API, but I'm just putting it there just to indicate that it's an API endpoint. We didn't have that earlier, and we need to mention an interpolation property. Just and that's it. So now our root endpoint has a version number, and we are dynamically using the version number here based on the API version attribute set. So let's run and see how does it come out. So Swagger UI is loading, and now our endpoints have changed to indicate that we have to use a version in the URI. If we open this, now we can see it's changed to version, and it's not a query parameter, it's a path property using which we can get. And now if we try this out, execute. So now our endpoint is API/v1.0/catalog. That's the endpoint it's tried, and the result is same. Now if we do, we have the version 2 result. So pretty simple, changing from query string versioning to URI versioning with this NuGet package is pretty simple. Now let's try the header versioning. So for header versioning, one change which we have to make is to add a version reader. We'll make it as new, let's header version reader. Yeah, API, new API version reader, and we can see the properties here. So we have to give we can give multiple header names also, but for now let's one header name, and we want to call it API version. Okay, and let's come back to our controller and remove the version. Let's just keep it API/controller and run it. Now it has changed to header, and if we try it out, we can see that it's sending a header value which is API version and the version number, and that's part of our header, and we're getting the response. Now one difference it has from API versioning and URI versioning is that now you, especially in case of GET endpoints, you cannot access them normally through a browser. because now this particular version number has to be part of your header. You could always access it and it will fall back to the default version. So say let's just try accessing this on a different endpoint, on a different tab, and we can see that it is loading all the values. It is falling back to the version, the default version. We cannot access the subsequent versions directly now through a browser. The only way we can do it either is using Postman or using the Swagger view. So this is one difference which is there from query and URI version. So there is nothing good or bad here. It's just that this is one important difference which you should keep in mind. Now let's go and change it to use media type versioning, which is the last one. Let's go back to program.cs and change this media type version trigger. So we have two overloads available for this. So if we use the default one, so when we are providing the accept header for accessing this endpoint, it would use the default mechanism which is given by this package, that is just v. So v equal to 1.0 is what we have to use, and it would start working. If we are using the default media type versioning provided by API versioning, then you can see that it supports the media types here itself, and that's how it works. If we go to second one, you can see it is 2.0, and if we try it out here, it will put that accept header and we'll get the data as we need it based on the version. Now if we want to have a custom type, content type to be used, instead of this, what we can do is use a new media type, API version reader builder, and we can change this builder.template application slash md.my-app.version plus JSON, and we'll have to add .build. So with this, it will create our media type API version based on this template. So let's run it. Now we don't have anything here. Let's try this out and see what we get. And it did a fallback to version 1. With the custom media type, it doesn't show up here in the media types, and if you go to version 2 and try it out, it still gives me the first version result because there was no accept header here. It went as explained. You could change it to application JSON and execute, and it sends the application JSON. So as of now, with this NuGet package, it is not supported to use Swagger UI with custom media types. So for that, we'll have to use Postman, and in the Postman we have to specify the accept header as the version we need, and we can test it that way. So that's one limitation as of now with this media type versioning with ASP versioning NuGet package. So that covers all the API versioning we can implement using this NuGet package. You can pick any one of these methods which suits best for your need. In my opinion, all are just different ways to achieve the same goal. API versioning is an important aspect of microservice architecture, and it's something you should consider when you are building a microservice based application, so that we don't end up breaking clients due to the changes in the services. We'll wrap it up here for today. More videos are coming out in this series, so keep watching this space. If you have enjoyed watching this video, then you should find something interesting to watch next here. Thanks for watching. See you in the next one. Adios.